In this video, I introduce VNet for volumetric medical image segmentation. VNet is a V-shaped deep convolutional neural network for volumetric medical image segmentation, which is trained end-to-end to extract features of MRI volumes through a dice coefficient-based objective function. Here is the architecture of a VNet model. This input MRI volume. There's a output, which is two-channel MRI volumes. A softmax layer uses this two-channel MRI volumes as input to output the probability distribution of the predicted voxels as a ground truth. VNet consists of a compressed path and a decompression path. The convolutions performed in each stage use a volumetric kernel 5 by 5 by 5 as shown here. This input feature volume, this output feature volume, and this 5 by 5 by 5 filter. As the data proceeds through different stages along the compression path, the feature map resolution is reduced, which is performed through a 2 by 2 by 2 kernel with stride 2 as shown here. The non-overlapping 2 by 2 by 2 convolution between neighboring stages extracts features from a 2 by 2 by 2 volume, which functions as a pooling layer. VNet doubles the number of feature channels as the resolution is reduced to half. P-ReLU nonlinear activations are applied throughout the VNet. Decompression path extracts features and expands the spatial support of the lower resolution feature maps to gather the necessary information to predict a two-channel volumetric segmentation. After each stage of the decompression, a deconvolution is used to increase the volume resolution, and then 1 to 3 convolutional layers with half the number of 2 by 2 by 2 kernels used in the previous layer applied, as shown here. This 2 by 2 by 2 volumetric deconvolution with stride 2. The final two output feature volumes with the same size as the input volume are computed by a convolutional layer with 1 by 1 by 1 kernel as shown here, which are then converted to probabilistic segmentations of the foreground and background regions via softmax layer as shown here. The VNet predictions consist of two volumes with the same resolution as the original input data, which are processed via softmax layer to predict the probability of each voxel to belong to foreground or background. The loss function L based on dice coefficient D is defined as here, where the sum is over the n voxels. Pi is the predicted binary segmentation volume, and Gi is the ground truth binary volume. The gradient of the dice coefficient is computed by using this equation. Here is an example of the actual views of predicted MRI image segmentation. For more details, please check with these references. Thank you. Bye.